My name is Inbal Sinai. I'm a senior front-end developer at Datarama, a Salesforce company, and working in Angular, obviously. A little bit about us. Datarama offers AI-powered marketing intelligence platform, which offers marketers a holistic solution. And as I mentioned a little over a year ago, we became part of the Salesforce family, which is pretty awesome. My job within Datarama is I'm building the Datarama Marketplace, which is a sort of one-stop shop for ready-made marketing solutions. I also contribute to various tools and libraries that originated in Datarama, some open source, many not. And one such open source library is Akita, which I'll go into a little bit at the end of my talk. And I also blog a lot about those tools, so you can check out my blog posts on Medium. This talk is about Angular structural directives, so again, not onPush change detection, so if you need some recognition with Angular, ideally. And also probably some recognition with Chuck Norris, because there are going to be some Chuck Norris images coming up later. So what is a structural directive? A structural directive is a directive that changes the DOM layout by adding or removing DOM elements. If you've been programming with Angular, that concept should sound familiar. This is because Angular offers a variety of structural directives out of the box. Here are a few of the most popular ones. You've probably been using these on a daily basis if you're programming in Angular. ngIf, which is either renders or doesn't render something based on the Boolean value of what it receives. ngFor, which iterates over an iterable object and just renders, in this case, for each hero, the name. And ngSwitch case, which is the inner directive of ngSwitch, which works like regular JavaScript switch, basically. Note that in each one of these, there's a telltale sign showing that it's a structural directive, which is there's an asterisk at the beginning of it. So what is that asterisk anyway? Well, the asterisk is what's known as syntactic sugar. It simplifies display that Angular offers us for ease of use. But then it converts it into a more complicated structure. Kind of like Chuck Norris does here. There's a much more complicated structure on top. Let's take ngIf, for example. Angular converts it into the following structure. It took our host element, the one containing the ngIf directive, and it wrapped it with an ng template. Let's try and create our own structural directive from scratch, step by step. Step 1, create a directive. So we've created a directive called myNgIf, which is basically a simple version of the ngIf directive we're all familiar with in Angular. We define the selector, like any other directive, and we define an input, which receives a Boolean value, which determines whether the host component should be rendered or not. So far, so good. Step 2, get a reference to that template. We do that by adding template ref in the directives constructor. As we saw, Angular wraps the host component with ng template. So we have a ready-made container we can use that Angular makes available through dependency injection. Now time to render the template in the DOM. Step 3. We start by injecting a new provider called viewContainerRef. So what is a viewContainerRef? Well, it represents a container, as the name suggests, that's responsible for managing the creation and destruction of views. We need it because we need to insert the DOM element, and to do that, we need to know where to put it in Angular's view hierarchy tree. That's the tree Angular maintains to keep track of what's rendered on screen. Not unlike the DOM tree the browser maintains, and indeed the end result is a DOM tree. Now, if you're old enough to remember the good old days of jQuery, whenever we wanted to add an element to the DOM tree directly, we needed an element to serve as the reference for where to put it. It often looked something like this. You see, the anchor element is there so we can know where to put the div. The corresponding mechanism in Angular is a container, and that's what view container ref is, basically. But wait a minute. What serves as a container in our case? Well, the answer to that is Angular replaces the ng template during the rendering phase with a diagnostic comment, which represents the container. And that tells Angular where to put it. If you look at the source, it looks a little like this. Let's return to examine the view container ref. The view container ref supports two types of views: embedded views and host views. Host views are created by instantiating the component with createComponent method, and embedded views are created by instantiating a template ref with the createEmbeddedView method, which is what we're using here. I just wanted to point that out. We're not going to go into host views any further. We're just going to use createEmbeddedView for our templates. A view container instance can even contain other view containers, creating a view hierarchy. So in our case, we want to create an embedded view, so we'll call the createEmbeddedView method, passing it the template we have as reference. When we want to clear the container, we call the clear method, and we either do that or render the template based on the condition we've got. And that's it. We have a simplified ngIf without the additional functionality we get in the built-in Angular one, such as handling else cases. But it works exactly like you'd expect. And by the way, the actual ngIf works slightly differently, not just because of the else, but also because of the requirement for performance reasons not to re-render the view unless the condition value actually flipped from truthy to falsy, because you can pass anything to ngIf. But if I pass it, 1 and then 2, the value changed, but it's still truthy, so there's no point in re-rendering it. And, that's bad performance. So this is our ngIf. Now, an even more powerful tool we have when creating our own structural directives in Angular is the ability to pass context. When we create an embedded view, we can pass it to a context object. But why would we need that? Well, because it contains all the properties which we want to expose to our consumers. Again, this is a clever little piece of syntactic sugar delivered by Angular. So let's create another structural directive, a range directive, to use this feature so we can see its capabilities and how powerful that is. This is the range directive. As you can see, asterisk again, structural directive. It accepts a range of numbers, in this case 18 to 80, and looping over every number in the range, it generates its given template for that value, exposing it in the template context. So that's the num that we see here. Basically, using a structural directive like this saves us from either A, manually adding the 63 option tags, which nobody has time for that, or using our very own, ng4 every time we need to do something like that, which is not, dry. So we want to create a directive so we can use the same directive every time. So here's our range directive. Similarly to the ngIf, there's a reference to its host template, as well as view container ref. Those are the two building blocks of the structural directive. It's cleared whenever the range is passed. And then we proceed to iterate over the range and create an embedded view for each number in the loop. As you can see, we're passing an object as the second parameter to the create embedded view method. That's the context. And in it, we defined a key named $implicit. And let me talk a little bit about that. This is, because this directive is not built just for my personal use. I want to build it so anybody can consume it. I don't know what variable they're going to be using to represent the current number in the range loop when they bind the template. So I want the user to be able to decide to use let num, like we saw in the example, or let number, or really anything they want. So precisely for that case, there exists this special property in the context object called $implicit. It ensures that when the user uses basically any variable name, it actually binds it to the value specified under the $implicit key in the directive. Any other value has to be explicitly named in the context object and referenced by that name in the HTML binding. But since we've used implicit, we can choose whatever we want. Here, I just chose my name, and it still works. Now let me introduce the ng template outlet directive. Under the hood, it does exactly what we've seen before. It inserts an embedded view from a prepared template ref, but there's an important difference. It takes a template and optionally also a context and creates the view. So here we can see the template, which displays a welcome message to the user. And in the components code, we pass the user's name inside the implicit context object. Let's see how we can leverage this ability to create easily customizable components. So here's a modal component. It can optionally receive as input templates to use as the header or the footer of the modal. Here's what its template looks like. As you can see, the bottom, we've defined default templates for the header and the footer, and we can use those in case they weren't defined in the component's inputs. In the center between them, we have an ng content, so that the user can pass the main content to display in the modal between the header and the footer. Now, as you might see, somebody might look at this and say, so why not use just 3 ng contents? You can just throw in whatever you want. Well, the reason is we don't get that behavior that we want, which is having a default template in case nothing is passed. That kind of functionality comes with ng template outlet. That's why we don't get we use that rather than ng content. So here's an example of how to use the modal component. Here I passed both a custom header and a custom footer, and my own content, of course. I don't use, by the way, a default template for the content because we assume if somebody's already consuming this, they have some content they want to show in the modal. So basically what we've seen here is the real power of ng template outlet, because the templates used in the component header and footer aren't static, and they're determined during runtime depending on what the consumer passed to the component. Time for some live coding. 1 second. Let me find the right browser. Great. Just need to, I don't have it here, so. So basically, this is all ready for adding a structural directive called if role. What it does is it basically checks what the user's role is, and it accepts as an input a role. It can also accept another role to be excluded, but basically it checks against its inputs to see whether the user is allowed to see the element or not, and based on that, it renders the element. Um, hang on, I need to get used to, yeah. Let's start by creating our service with our roles. Hope I don't have too many typos. So we have user, viewer, admin, and Chuck Norris, who can obviously see anything because he's Chuck Norris. You know, Chuck Norris doesn't do push-ups, he pushes the planet down. So let's put some values here. We have a role. It is a new behavior subject of type roles. Yeah. Okay. This is our initial role until we decide otherwise. Let's expose that. As an observable. And let's give the service the ability to update the role. I hope that's clear. That's basically all the functionality we need from the auth service for this example. Let's go ahead and go to our component. Yeah, let's create a template for it. Let's do some content that anybody can view apart from an admin. So I need to use the if role. And I'll give it roles, but first I need to add roles to my component, so let's do that. So roles viewer and anybody above, which is admin or Chuck Norris, can view this, but I also add except roles admin. This is a specific syntax that tells basically Angular to expect these inputs. So it expects now an input in my directive called if role. So I'll just add that. And another one for the exception. Now, let me just check. Oh, I forgot. This is harder than I thought. Yeah. See what's wrong here? Oh, maybe, yeah, that should not be here. There we go. Yeah, no problem. Back here, now let's add some content. Let's add another div. And make that content viewable for admin and above. So I just need to enter one parameter here, roles admin. Yeah. should have checked earlier. Hang on. Hang on 1 second. There we go. And one last one for Chuck Norris, very special one. Here we go. Okay, that's all the content we need to display. But we also need to toggle the user roles. So let's add buttons to do that. Oh man, finding all kind of stuff about my typing ability here. Okay. So this is the button that will basically cause our user to become, to get the role of viewer. And we'll add one for each role. So. Okay, now we need to implement the update role, and we need to actually update the role. So to do that, we go back to our component, and we add in the constructor the auth service, because that's what's in charge of managing the role. And now we can use update role. It gets a new role. And all it does is call the auth service to update it. Hang on, let's see what's missing here. Template. Oh, another tacos, but wrong. Let's see. Just fix all of these. Should be okay now. Yeah, here we have our 3 buttons. And basically all that's left is the directive itself. So let's go on and implement that. So we already saw that we have the 2 inputs set up. Let's add the constructor. Now, if you remember, there are 2 building blocks for every structural directive. One is the template ref. Actually, you don't need to remember, it's just up here. Oh, the template ref should get any. That's basically the type of the context. And private view container ref, which is what does the actual create embedded view. The third element of the constructor should be the off service, because again, we need to know the user's role as well for comparing them. So almost, hang on. Okay, that's our constructor. Now let's use all of these to generate the template, to render it. Well, first we take our service and we created an observable so we can see the role at any given point. And we can subscribe to that. We get the user's role. And it's time to compare it, right? So we're making actually two comparisons. So one is checking the user's role and seeing if it's the same role that we gave our directive or higher. So an admin can see viewer and Chuck Norris can see admin and viewer. So this role is what we got from the input. And also we have the ability to exclude a role, so we need to check that this role wasn't excluded. And if everything checks out, we take our view container ref, we call create embedded view, and we pass it our template. As you can see, the template for anybody, apart from the admin, is already rendered because the default value of the user's role is viewer. But as you can see, there's still work to be done because nothing here is cleared. So we need to clear it every time the value changes. So to do that, I'll add a pipe. And I'll add first the distinct until changed, just for performance reasons. So, and then I'll add a tap. Which all it does is, actually I don't even need those. If there's already something rendered, I'll clear it. Last but not least, let's add some Chuck Norris-based CSS. And we should have the full functionality. So as long as I'm a viewer, I can see this. As long as I'm an admin, I can see this. So I can't see what the other div. And if I'm Chuck Norris, I can see everything. So that's the IFRL structural directive. As you can see, it's very powerful. It gives us a lot of functionality with very little amount of code. So let's get back to the presentation. Yeah. So finally, hang on. Yeah, I want to talk a little about Akita. Akita is a state management solution that we developed here in Datarama. It's framework agnostic, so you can use it with Angular, React, and pretty much everything else. Vanilla JavaScript, Vue, Svelte. It's very easy to pick up. It makes life so much more easier because it just saves you a lot of boilerplate and gives you extremely powerful tools to manage your state in your application. It's been out for a little over a year now, and it has 446,000 downloads so far. It's built on top of RxJS, and I encourage you to try it out. There is very extensive documentation as well. These are a couple of links for more articles about structural directives. In case you have any further questions, that's it. Thanks from me and from Chuck Norris.
Do you have any questions? You have a couple of minutes to spare.
Hello. Yeah. What would be the React alternative to the structural directives?
Well, I'm not that big on React, so I can't tell you for sure. You have to look that up.
Okay.
I've been programming with Angular pretty much since Angular came out. So.
Okay. Thank you.
So we have time for another question, if you would like to ask.
No. Okay.
All right. So thank you.
Thank you.